call the long distance across an ellipse?
Major
It's
axis.
the major axis. That is correct. It's the major axis. And so what we use, we don't use the major axis, of course, because we don't want the whole thing. We don't use the diameter. What do we use? Radius, right? And so into these equations, what we're going to use is this thing. We use the little letter a for it, and it is the semi-major axis. So if you have to use these equations, if you're going to use these equations here and try to set them equal to each other, instead of using r as the radius of a circle, because we don't have a circle, we're going to use our little letter a as the semi-major axis. And oftentimes you'll see this expressed as the average distance. And I suppose it is the average distance, right? Because if you look at it as far away as it could be and as close as it could be, the average there is going to be basically halfway between, right? So semi-major axis. Is that cool? All right. So we know it's about 93 million miles is the average, which is cool. I'm happy with that. It's a little bit not, because if you add this and this together, you get 95.5, so it's really close to 92.5. It's fine, it's just like that. Because what we do is we say that the average distance from the Earth and the Sun is 1 AU. And that is an astronomical unit. Okay? 1 AU is an astronomical unit. We use astronomical units to measure the distances to things within the solar system. Outside the solar system, we got to use light years. It's a whole different ballgame. What?
I was just asking a question.
Okay. So as we look at the solar system, we got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We can just use the 8 major planets. I'm okay with that. As you get farther out, do you think it takes more time, less time, or the same time for the planets to do one complete orbit? More time, less time, at the same time. What's your gut tell you?
More.
It takes more time, right? So here's what you guys are going to do right now. Cool. I want to know this. Here's my planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. I want to know if we could plot this here and come up with something interesting. So let's make this the distance in AU. And let's make this the period in, let's do years. That'll be easy. For each planet. And we're going to look this up and we're going to see if we can't figure out what kind of relationship this is. Is that cool? All right. I'll do the easy one for you. I'll do Earth. Here's Earth. How many AUs away is Earth? 1. Nailed it. And how many years does it take to go around? Okay? So Mr. Lefebvre, please look up Mercury. You do Venus, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and you do Neptune. Okay? You look up Mercury, Venus, Mars, and they do Jupiter, and you do Saturn. All right? So look up these two values for them, and I will write them up here. when we have a consensus. Please do that now. I have to finalize the grades from third quarter today or tomorrow. So check them to make sure they're good. If you have any comments, try to let me know today so I can fix it tonight, okay?
Did you know we have a half day on Thursday?
Do we really?
Yeah, I found that out this morning and I was like really confused.
Half day?
Yeah.
I did not.
I'm excited.
I wonder if they're gonna make me do stuff. I mean, they don't just give us the day off, we have to do something.
Yeah, they're probably gonna make you do like PB or something. How fun is that?
All right, who's got Mercury?
0.39.
0.39? What day did you get 0.39?
I got 0.4, but yeah, close enough.
And what about the time to go around?
0.24.
Point what?
0.241.
It only takes 0.24. It only takes a quarter of our year for Mercury to whip around. Woo-hoo! That's awesome. All right, who's got Venus?
It's a quick.
It is. Go.
0.7.
0.7? Does everyone else get 7? 7? What was the period?
I have 225 days.
Can you make it into years?
0.616.
How much?
0.616.
616. Excellent. Who's got Mars?
I got 1.5 for the distance,
1.5.
and I got 1.88 for the year.
Now, right away, I'm noticing something, okay? I'm noticing this can't be a linear relationship. Because since I have the point 1, 1, if I multiply my distance by 1.5, I'm seeing that my period is now multiplying by 1.5. You see, this is not a linear relationship. That's frustrating and annoying. Who's got Jupiter? Anthony?
Oh, I
Oh.
had 5.2.
Is that right? You got 0.2? And Ben, what was the,
For the orbit, I had 12 years.
12?
12.
Anthony, is that right?
Yep.
Okay. Saturn?
I had 9.951 KU. 9.95.
And how much time?
29.4 years.
29.4. Yikesers. That's cool. What about Uranus?
19.8,
19.8. And?
84 years.
84? What? So now we're looking, clearly this is not linear, because this is like times 20 and this is times 84. That's not linear. There's got to be some sort of up curve. The problem is, it's not quadratic either, because if this were times 20, for quadratic this would be times 400, because 20 squared is 400. All right, what about the last one? Who's got Neptune?
31.64.
31.6 and?
164.9.
Okay. I like it a lot. You guys good with these? All right, open up a Desmos or an M plot or something that you want to graph with. Okay, we're going to plot A and astronomical weakness down here. Plot T and weakness here.
Let's see if they fix the Wi-Fi.
What's that?
So let's see if they fix the Wi-Fi.
Was it broken?
Yeah, they like fixed it yesterday, like shut it down and then screws was out.
Oh, really?
They like sent us a message.
Well,
We're working on the like system.
I was going over.
Oh. Get a lot of quick, like a bunny. I don't think that fits good. All right, everyone got it? All right, get there quick like a bunny. So I sketched it on the board real fast, of course, and then now we're going to look at it over here. So one of the things about this is that we got to try to fit it, yes? That's the whole point here, is we have to try to fit it. Now, what I love about Desmos is that I'm going to see if it's linear. So I'm going to say my data is y1 squiggle m x1. Okay? Now, we have a 0, 0 intercept here, which is appropriate. Okay? And what do you notice about this? Does that look good to you? No, it doesn't look good, and I don't have a sense that it's linear anyway, right? Let's try y1 squiggle m x1 squared. How does that one look? Does that one look good? No, that doesn't look good either. What I'm noticing here is that the black line, the linear, is kind of above, and the red line is kind of below, and then they switch here. And so I think that the exponent on the black one is not enough, because it's not curvy. but I think the exponent on the red one is too much. You see my problem here? Like if I look back at this one, remember, a linear is x to the first, right? And parabolic here is x to the second. So what are we going to do here? I mean, how are we going to fit it? Does someone have a suggestion? Is there something we can do here? What do you think we can raise it to fit? I mean, if 1 is not enough and 2 is too much, yeah.
Raise like 1.5.
Look at that.
Whoa.
What do you think about that?
Seems odd.
It's the most amazing thing ever. In the late 1600s, this dude hanging out in Denmark was like, man, I wonder if there's a relationship between the distance and the time. And he plotted it, and he's like, well, it's not the first power, it's not to the second power. What if it's to the 1.5? And he drew his line, and look, it fits perfectly. So here's what we got. We have the time in years is equal to some coefficient times the distance raised to the 1.5 power. Now, I know no one likes fractions. Okay? I know no one likes fractions, but we'll get over ourselves. Is there a fraction version of 1.5? Okay. So t is equal to some coefficient, a raised to 3 divided by 2. Now, I don't particularly like fractions, right? So what can I do to this side to get rid of the 2, just to, right, to get rid of the fraction? What can I do? Can I square both sides? Right, you can, right? So I'm going to take this side and square it. I'm going to take this whole side and square it. And that's what t squared is equal to some coefficient times a cubed. What's our coefficient here? Oh, no! Are you serious? No, I want to finish it. I need to finish this.
Also, did you get my school addresses? Still, or did you see my assignments?
Will it not let you upload them